out on time, so we'll get started here. You can hear me all right in the back there? All right. Thank you for joining us, day 2 of Summit, to talk about the most exciting thing in the world, data lakes. Right? I'm sure that's why you got out of bed. My name is Jason Molden. I'm a senior solution architect with Amazon Web Services who gets the privilege of partnering with our state and local government customers to design technical solutions to solve their business problems. And today I'm joined on stage with Mr. Derek Lee from the state of Minnesota.
Good morning, everybody. I'm Derek Lee, data architect for Minute at MDH. I'm going to be talking about how data lakes helped us in the COVID response in the state of Minnesota.
Well, thank you. And the title isn't burying the lead here. Today we're going to talk about the common data challenges that we see that affect every organization. We're going to layer on the lens, the context of public health and healthcare, but it's the context, the story, the patterns architecturally here is all going to be interchangeable with your own specific domains. We'll talk about that here in a second. So, real high-level overview of the agenda, right? So we're going to talk about the importance of data. Not only the challenges we face with data, but also the opportunities that await your business when you find a way to harness that data. We're going to talk about public health, data lake trends, the global trends and considerations when designing your data lake, as well as we'll spend the second half of the session diving deep into the state of Minnesota's architecture, the business problems they solved leveraging a modern data architecture, and where they're taking it next. So, what does it mean to be a data-driven organization, and why do we continue to emphasize data-driven organizations? Every business, I don't care if you're education, federal financial, healthcare, it doesn't matter, you're a data business nowadays. And that data is growing exponentially. It's no longer a linear path. In a prior life, I ran data centers. I was a technical architect for a university. I bid my storage arrays for 5 years at 10% growth, maybe 20% growth, and that's all the data that I could handle. Data doesn't flow that way anymore. It's growing faster than ever and coming from more sources than we ever imagined. And these days, industry analysts talk about the fact that 70% of that data remains dark. That means we're only creating actionable insights from 30% of our data. And I put that in context because I'm from Minnesota, so I'm a fair weather Vikings fan, but if my quarterback can only make decisions based on 3 of his players, how does that impact his game? How does that impact your business when you're only looking at 30% of your data? And this is from the commercial side. On us government agencies, I'm going to go out and assume that we use even less of that data. So what does that mean? It means that you're missing that opportunity. Again, you're missing the chance to make actionable insights from your data. In simple terms, a data-driven organization is about getting the data in the hands of the right people in the right amount of time, but also doing so in a way that doesn't introduce any more risk by having that governance layer on top of it. We'll dive deeper into that in a little bit. So let's talk about the 3 trends we see in the data realm. Data growing faster than ever, explosion of data. We're seeing an explosion of personas, people that want access to that data. As more data becomes available, more people want access to that data. And finally, we're seeing the demand for people to be able to make database decisions quickly. 3 key trends, and it's broken down to like 5 little buckets here, right? So talk about explosion of data. In the healthcare realm, we're seeing consolidated clinical documents, electronic health records, HL7 messages. They're coming from more sources and faster than ever. We're seeing states like Utah, just a couple weeks ago on a webinar, talked about how their syndromic surveillance or their disease surveillance systems grew 1,000-fold. Typically, we're talking at most healthcare agencies I work with, we're looking at 4 times increase in the size of their immunization information systems. And they still can't keep up with the amount of data coming in. Furthermore, we're getting it from more dispersed sources. People aren't going to their primary care physician anymore. They're getting their COVID tests through online sources, state-run sources, primary care physicians, at the CVS down the corner, and all this data is coming back into your central organization in different formats. It's coming so fast that you don't have the time to define schema. You can't go out there and say, I want the data exactly in this way, because it'll take too long for everybody to follow that schema and send it to you. You're making choices that say, give me the data and I will figure out what to do with it on my end. So explosion of data, explosion of sources, and then the increasingly diversity of file types, right? Again, there's insights from a lot of different data sources. It's no longer structured, semi-structured. It's no longer coming from our line of business applications, our databases. There's a lot of data in unstructured sources like video, audio, scanned documents. Most of us here are public sector, so government loves forms. Can you extract insights from those paper forms and use that to inform your decisions? And again, we talk about the explosion of personas, right? And we need to present that data in a different way for each persona that wants to extract insights or make decisions based on that data. At the governor level or the state level, you're rolling up that data, all the way down to the individual consumer, the individual healthcare providers, the epidemiologists at the state. They need different views of that data. And how do you control that and make that happen? How do you reduce that mean time to insights from discovering data? And then finally, it's not only people, but many applications, right? There isn't one BI tool that every agency uses. There isn't one specific tool to extract insights. Maybe you want to layer on machine learning. Maybe, some of your departments, have different methods. You want to make it flexible, the ability to extract insights from that data as flexible as possible. That way, whomever needs access to that data can get access to that data using whatever tools they want. So a lot of challenges, right? And again, we look back and we're using public health terms, but you can just substitute those words with your data sources. If you're in education, right? Maybe it's your student information system, your learning management system, your Diebold, Seaboard, doors. Data comes from a variety of sources. But with those challenges, when you overcome those challenges, you have the opportunity to take advantage of some of the opportunities here. In healthcare, again, it's all about informing decisions. Are we able to merge data sets to get the full patient picture? Right? A lot of the data that comes in from the labs, from the COVID tests, from the vaccination reports, that's not the full person. Can you merge it with demographic data, location data? You have all these other disparate data sources and silos that you can bring together to paint that full picture, to find out where your swells are. How is that impacting your community? We can use this for interventioning decisioning. We can use this for efficacy, right? Can we make our data platform more like a DevOps practice where you get short in your feedback loops? We institute this policy based on data. How soon can we review the analytics and determine whether or not our policy, the decisions we made, are actually doing what they intended? It's possible today in the modern data architecture. The traditional methods of siloing all that data off in independent systems doesn't have the flexibility, doesn't have the ability to expand and handle this increasing volume to make this happen. So, again, substitute your specific words, your specific domain language with these methodologies, but this is all absolutely achievable with a modern data platform. So how do you become a data-driven organization, right? And we talk about it's not just about the technology. That's the focus of today, but becoming a data-driven organization starts with defining your business needs and working backwards from there. It's about having the flexible platform that can scale with your needs, be able to accept any form of data. Again, we don't care if it's structured, semi-structured, or unstructured. We want to be able to ingest that into our data platform. And it needs to be able to be performant, compliant, secure, resilient. Working with our retail side, Amazon.com, we've learned a lot about modern data architectures. Working with our customers, such as the Minnesota Department of Health and the states across the nation and our federal partners, we've learned a lot about becoming an effective data-driven organization. And it usually follows these 4 steps, right? Making sure your platform is scalable, reliable, performant, secure, making sure that your architecture enables your analytics and data scientists easy access to that data. The data platform and all associated processes must be well governed and controlled, and the organization culture has to change with that. Just like the DevOps movement, just like the Agile movement, just like cloud. Handling your data in this way requires a cultural change. You have to think about things differently. You have to accept that there isn't one tool to rule those all. We purposely design our data structures. On the right-hand side is a flywheel. And anybody familiar with Amazon and our flywheel methodology, it's all about building a self-sustaining system, having inputs that drive outputs. And we're going to dive deeper into that in just a second here. So, in the analytics flywheel, again, using the lens of healthcare, we're going to take more data, faster data, our genomic trace sequencing, our CDC data, getting all these HL7 feeds, our electronic lab records, our immunization information system. Substitute your data sources with what applies to your domain. More data equals better analytics. Can we use this data, again, to paint the whole picture of a patient? Can we do predictive modeling? Can we merge it with other data sets? Can we do patient matching and deduplication? Again, is J. Molden the same as Jason Molden, the same as JL Molden? If I go and get 5 different COVID tests in 3 days across 5 different sources in the state of Minnesota, can they tell if I'm the same person? How do you do that without a specific unique identifier and each system reporting their own things? You need to be able to layer on machine learning models and deduplication on top of that. And to do that, you're going to have to merge it with other sources. So more data, better analytics. The better analytics, the more meaningful impact. Again, can we make faster decisions? It's all about mean time to decisions. How does this have implications on public policy? This isn't unique to healthcare. Pretty much every organization is going to inform their bosses or their hierarchies in some way, shape, or form. And again, we talk about efficacy. Can we shorten that feedback loop? Can we determine if the policy we put into place had its intended effects? Can we do it with data, and can we do it fast? The better the impact, or the more meaningful the impact, the better the analytics, the more users they're going to want to have access to data. The more users that come in, the more data that's going to come into the platform. And this flywheel is going to continue to power itself over and over again. And I'm sure Derek will talk about the flywheel that Minnesota has created here in a little while. So how do we enable this flywheel? Again, we kind of talked about these 4 categories earlier, but it's all about the inputs on the upper left-hand corner, the data and the people. It's about getting the data into it and treating it as an organizational asset. From the data platform perspective, it's got to be able to scale to handle vast amounts of the data. It shouldn't matter if you're getting 10 times the amount of data in one day. Operationally, it should be the same, and it should not affect your SLAs to when you can analyze that data. But getting the data into your data platform is only a piece of this. The other components of the flywheels are the analytics over on the right-hand side. Here you need to be able to democratize the data. You want to make it easy for your analysts and your data scientists to have access they need and the tools and the equipment they need to gain insights from that data. And finally, we layer governance across the whole thing. The goal is to enable your analytics teams the ability to make better decisions and drive these new innovations in a safe and secure way. This data platform that enables this is what we call data lakes on AWS. A centralized repository for any amount of information in any format. The power of the data lake is it allows you to do real-time analysis. It gives you that faster mean time to insights. And we're going to dive really deep into the data lakes in just a second here. So again, it's all about you gaining business value from your data. So how do we do that? And you've got a lot of options on AWS. When we look at it again, it's about 5 primary overarching categories, right? It's collection, ingestion, storage, and analytics, all wrapped up in governance. Governance here, I'm talking about the 3 A's and E, right? The authentication, authorization, auditability, and encryption. Layer that on top of everything. The first is the ability of your platform to handle the increasing volumes and velocity of data. We kind of talked this a little bit earlier. I don't want my data scientists to be impacted by the data sources changing. So how can we do this event-driven? How can we make this faster? How can we scale our infrastructure independently? Each one of these components needs to scale independently so that one doesn't impact the other. Again, we're kind of like decoupling, just like DevOps, just like the agile movement. Similarly, as an analyst, say you want to query 10 years of records. You don't want that to take any more time than a subset of the last 10 days. So how do you design your data platform to be that flexible to be able to handle that? And finally, again, we talk about the flexibility. There isn't one tool to rule them all anymore. You need the flexible. And AWS simply provides broader, more depth and flexibility than any other cloud platform. So we're going to go through this really briefly. The data types, right? Structured, semi-structured, unstructured. It doesn't matter. It shouldn't matter what type of data you need to analyze. Furthermore, you may have databases. Again, on AWS, you have the flexibility to use databases that match your workload. No longer is there one relational database to store all of your stuff. If you have NoSQL data, we have Dynamo. If you have Quantum Ledger data, if you have time stream data, if you have graph data, build your applications and your data structures to match the needs of your business. Don't try to ram it into one traditional database. Once you have the data, you need to have a way to get the data into the data lake, right? And there's two primary methods. You can do batch, the traditional batch mode. Here we've got a lot of help. We've got our transfer services, over a dozen different ways to move information into S3, including APIs, SFTP, everything fully managed, database migration service. Some businesses require streaming data. Here again, we have options. You have Kinesis, you have managed streaming services for Kafka. All of this pushes the data to your S3 bucket. Your durable, near infinitely scalable, secure data platform. Now we talked about that S3 designed for 11 nines of durability, 99.9% availability, regionally redundant. It is a fantastic spot and cost effective for you to store all of your data. Once you get the data into S3, you're going to run analytics on it. Again, you have options. There's no one tool to solve all of your problems. You slice and dice and pick the appropriate one for your needs. Here you got things like a traditional data warehouse solution with our Amazon Redshift. Maybe you want to run distributed Spark jobs against it. We have Elastic MapReduce. If you want to just have your data scientists or your analysts dip their toes into your data lake, you can use our serverless Athena just to query the data where it lies inside of S3 and gain instant insights from that. Again, if your organization is competent in machine learning, that's a core competency of your organization. You can leverage Amazon SageMaker, create models, run machine learning jobs. But if that is something that you're not familiar with, if that is not a tool inside of your tool chest at your organization, we've got over a dozen pre-trained ML AI models that you can layer on top of your data lake to extract more insights from that data you have present. And of course, we talk about catalog and governance. Here again, you have options. It's flexible. You can use our managed solution, AWS Glue, which crawls your data, infers schema, catalogs it into the Glue metadata catalog. If you want to use your own Hive metastore, go ahead, use it. If that's what works for your organization, that's where you have specialty, and do it. A lot of our customers also use partner solutions like Informatica or Colibra at this layer. The choice is yours. You have flexibility here. As far as governance, we have a platform called Lake Formation, and this again is the authorization layer across your entire data platform. All built into our ecosystem, works really friendly with everything we have here. And finally, I can't be on stage as a solution architect without talking about the well-architected framework. We layer on security, reliability, operational efficiency, performance, and cost optimization across the entire platform. So this eye chart is a little overwhelming. I'm going to freely admit that, right? There's a lot going on here. But the point of this is to talk about you have options. Again, you have flexibility and tons of tools inside your AWS tool chest to make this happen. And if it seems overwhelming, I'm sorry, but you have people like me, you have partners, you have professional services, there's tons of white papers out there, case studies, examples about how others have done this, and we're more than happy to help you decide which components of this are right for you and which ones can help you achieve your business results. So let's dive a little bit deeper. Let's look at a sample reference architecture here for syndromic surveillance. I got a couple sample reference architectures, so I got to have a check here. It all starts, on the left-hand side again. We're getting data. Data's power in our flywheel here. For public health, it's all about the labs, the providers, sending their data into the data lake. Here we're going to use transfer family. Traditionally, a lot of the hospitals, a lot of the clinics are going to SFTP that information, and we can still do that. We can use the same process that you're already familiar with, or we can layer on additional processes. Once it gets into the data lake, into our S3 bucket, we're going to want to validate that data. Again, we have a serverless platform called Lambda, which is event-driven, and as soon as that data lands in the S3 bucket, it's going to perform that data validation right off the bat. This has a couple different benefits, right? Lambda, again, serverless, so super low cost. Event-driven, so as soon as that data hits the S3 bucket, we're going to perform our data validation and trigger the next process, so it's super quick, lowering that mean time to analytics. And it's also extremely cost-effective because you're only paying for the microsecond or second of data execution. You're not paying for that server to be running 24/7. Once the data's perform your validation, we're going to look at something, maybe ETL. Maybe we want to use Glue Data Brew. Maybe we want to use just our Glue jobs to perform some basic ETL on that data. Then we'll trigger an EMR job, run some Spark, some machine learning models on that, put the results back inside of the data lake, recrawl it with glue. Again, all event-driven, all seamless. Then we perform our insights. Again, dipping your toes, you could just query it with Athena. You can tie your applications, tie your BI platform right into your Athena queries if you want. You can dump it into a Redshift data warehouse if you want. You've got lots of options. You can perform additional analytics. How quickly can you get data to your analysts? You know, in my days of running data centers and managing data warehouses, somebody'd come to me with a new data source and it would take weeks at best, maybe months, before I could get that into our data warehouse and people could actually query those data sources. This can be done really fast. So we're going to take the same basic process, because again, it's the same process, we're just going to interchange different components, right? So here, we're going to take unstructured data, we're going to take video, we're going to take those scanned documents. Same sort of process, we're going to use one of our more than a dozen transfer services and ways to get that information into S3, drop into the S3 bucket. Trigger an event-driven Lambda function that triggers our pre-trained machine learning, whether it's transcribe, turning audio into text, or textract, scanning those form documents using natural language processing to pull form data out of your scanned documents. Dump that information back into the data lake. Maybe funnel it through our Amazon Comprehend or Comprehend Medical. Let's label these entities. Let's automatically, using pre-trained machine learning models, scan that data, pull out medications, prescriptions, location information, PHI. Put that information back into the data lake, catalog it, perform analytics with SageMaker or any other platform of your choice, and then gain insights quickly. What's beautiful about this is it's completely serverless again, right? You're using your smart people to focus on the data rather than managing, patching, and maintaining servers. And it's all interchangeable. We talked about each piece being independently scalable and interchangeable on an earlier slide. This is what it's all about. Especially, you know, on the bottom right corner, the machine learning, the SageMaker, things like that. Because you never actually load that information out of the system, you query it where it is inside of your data lake. Say you want to tune some of the knobs and dials. You want to rerun a model. You want to experiment, iterate, check for new things with your machine learning models. You can do that in parallel to your existing process because you're never actually moving that data outside of your data lake. And again, they're serverless, so you're going to stand it up, you're going to experiment, you're going to shut it off, and you're only going to pay for what you use. It gives you the power to innovate, iterate quickly. Final reference architecture, again, we're just going to interchange some of the components. It's the same basic process. Say you're a traditional structured shop for your data analytics, data warehousing. We've got Amazon Redshift, our exabyte scale data warehouse. The power of Redshift is through federated queries from one spot, from your Redshift. You can query not only the information inside your Redshift, but the data inside your data lake in S3 where it lies, and also your line of business applications, your operational databases, all from within Redshift. One place to query all those data, to join all those data sets, to run your machine learning models right inside of Redshift if you want, and have access to all of your other data without moving it around. Very powerful, and this is what we call our lakehouse architecture. So with that, I've talked, really hypothetically, we started at the high level of what data lakes are, what the importance are, why it's so important to become a data-driven organization. We talked through some reference examples, but it's this pattern, and this pattern is applicable no matter what your business is. You just substitute the inputs and the outputs to apply to your specific domain. And now Derek's going to actually talk about what the state of Minnesota did and how they leverage this technology to solve their business problems.
All right. Thanks, Jason. Yeah, thanks, Jason. And thanks, everyone, for coming out here this morning to listen to us talk about data lakes on AWS. I'd really like to talk about the pandemic journey that Minnesota IT and our data team has had supporting the Minnesota Department of Health in our state's pandemic response. We've come a long way, and we've learned a lot, especially relating to data lakes and the role that they played in supporting our response. And I'm hoping that the lessons that we learned can be useful to you as well. So, going back in time to March of 2020, feels like a lifetime ago at this point. We really didn't know what the future was going to bring. We knew very quickly that it was going to be it was going to be a very difficult journey, that things were going to have to scale out very rapidly. We had no idea what data volumes we were going to have to deal with. We had no idea what kind of analytics we were going to need to perform. We didn't go into it necessarily with any architecture in mind for what this pandemic response was going to have to look like. We were forced to improvise very quickly. What we found very quickly was the extent to which our data was ramping up. With our caseload in early 2020, our baseline was under 10,000 new cases in our disease surveillance system per week. At the peak of the pandemic, that expanded, around ninefold. So it was a completely new paradigm for how we were going to have to support the Department of Health in their work. Very early in the pandemic, as with everybody else, there was some degree of chaos. A lot of people at the health department and elsewhere very quickly improvised solutions for their own particular use cases. There were a lot of forms and surveys that were stood up very quickly in order to acquire data for case management. Of course, that was extremely difficult to manage. Within the space of just a few weeks, we collectively came to the conclusion that all of this was going to have to be housed in our main disease surveillance system for the state, known as MEDS. And that led to essentially this design for how our systems were going to have to integrate to support the pandemic response. So as you can see, MEDS here is the central component as far as our integration point, our central component for our source of truth for data throughout the system, which posed a number of problems for us because it is a vendor system that's deployed on our AWS account. We had relatively limited ability in order to change how it worked for our particular needs. The actual application itself, we had relatively limited ability in order to actually scale it out for the particular needs that were going to be met here with analytics. So we were forced very rapidly to come to some significant decisions on what we were going to do to support the pandemic response. We were going to have our analytics platform be something that was going to scale out essentially indefinitely. It was going to have to be able to support pretty much any stream of data that we could think of, because there were going to be integration points to external and internal systems that we couldn't even foresee in the early stages of the pandemic. We were not going to certainly we were not going to have any control over what systems we could actually integrate with, or what requirements we had of the data coming in from them. We needed to have something where we could iterate very rapidly with the underlying infrastructure, with the kind of analytics that's deployed on top of it. Fortunately, just before the pandemic, a group of us at State IT had gone to an AWS data lab and had learned a great deal about data lakes on AWS and the role that they had to play and exactly how to deploy them and use them. So by April of 2020, it was pretty clear that this was going to be the direction that we were going to be going in, and that one of the first data lakes that we were going to deploy in our environment was going to be for our disease surveillance system. So for our first iteration with that, we had very limited time in order to actually get something done. We had extremely pressing analytics needs because some of the reports that were against our disease surveillance system were failing already, weren't meeting the needs that our epidemiologists had, and weren't delivering results in time that ultimately were going to be sent to the Minnesota Governor's Office for critical pandemic decision making. So something was going to have to be done in order to have more suitable analytics come out of this system. So because of the experience with the AWS Data Lab, what I was able to do was use lake formation blueprints to deploy a workflow in Glue, which is essentially a collection of orchestrated Glue jobs. I was able to deploy that in Glue going against our disease surveillance system database, which pulled the data into S3, crawled it, made that data available in tables in the Glue data catalog and available for querying in Athena, and have all of that encrypted and secure in the space of a few hours. That allowed me to work with one of our lead epidemiologists, who is essentially the first driving customer for this, for creating some of the reports that landed on the governor's office desk. We were able to iterate creating some of those reports in Athena just through SQL in the space of a couple weeks, because it was essentially tools that were already familiar to all of us. And that report met the need. The data lake refresh was set on a schedule for twice daily. It went like clockwork. Everything just kind of operated seamlessly, and it met the need beautifully. Very rapidly, other epidemiologists in that team started having requests for additional reports coming out of that data lake. Anticipating the direction that this was going to go, it became apparent that we were going to need a refresh more than twice daily, that both epidemiologists and senior management, people at the executive level, were going to need data about pandemic response in near real time. Twice daily was just not going to be sufficient. So we had to come up with a solution for that, kind of anticipating what that need was going to be. Also taking lessons out of the AWS Data Lab, I pursued creating a prototype using database migration service in order to stream change data, capture data out of our database and into our S3 environment. Once that data was streamed into S3, it was a simple matter in order to set up a Glue crawler and again make all of that data available in Athena for querying. At that point, there still wasn't the stated need to have real-time querying out of this system, but somewhat unexpectedly, there was the drive for creating what became Minnesota's COVID-aware app, essentially COVID exposure notification, working with the PathCheck Foundation. And having the streaming data going into S3 and having it available in near real time, and also importantly, having change timestamps associated with all of this data so that we could essentially do point-in-time queries automatically with this data, made it a really logical place to serve as our foundation for creating our COVID-aware app. We were able to do that within the space of a couple weeks and have that stood up. What we found out for a period of time is that that worked really well, but then it gradually became more expensive and less performant because we were simply streaming the data into our S3 environment, and that led to a large number of small objects on S3, which you find out pretty quickly is not optimal, both for Athena performance and Athena cost. So we knew that we were going to have to come up with something that was going to collapse that data down, and essentially when we had updates streaming into our data lake, to be able to perform some kind of upsert into our data lake environment. This was a new kind of problem for us and not something that we had really had a chance to talk about at our AWS Data Lab in March of 2020. So what we did at that point was come up with with the assistance of AWS architects, come up with some potential solutions for what the architecture of that might look like, and then requested another AWS Data Lab, this time remote, in order to pursue all of those possible architectures and find out the relative pros and cons of each of them in our environment to come up with an informed decision on what direction we wanted to go. So one of the alternatives that we had in mind with this was to use the open source Apache Hudi project, which is essentially is a set of tools for performing that kind of upsert and for having transactions on a data lake, whether it's in S3 environment or on-prem in Hadoop. At pretty much exactly this time, AWS announced the support for Apache Hudi, the ability to query it using Athena. And that essentially decided it for us, that this was going to be the logical direction for us to go in. With some AWS help in coding out a template for deploying this data lake, for having an elastic MapReduce job using Apache Hudi, with DMS loading the change data capture into S3, curating the data into a separate S3 location and crawling it. With AWS help in creating that template, we were able to roll out this version of the data lake quite quickly. And because all of the analytics infrastructure that had been deployed on our previous model of the data lake was simply Athena queries, it was a very simple matter in order to transfer that over into our new data lake environment seamlessly without the business even having to do anything. And everything just kind of worked perfectly at that point. At that point, we had near real-time ability in order to pull any of the analytics that our epidemiologists and our senior executive level needed for pandemic response with latency of only a few minutes. So where that's led us with this is that over the last several months, where we've had a lot of experience with this, there have been some pain points with this system. It has worked, but we don't have a whole lot of experience in-house managing elastic MapReduce clusters. It's substantially lower maintenance than managing a Hadoop cluster on-prem, but it is significant maintenance. It requires some expertise. And in particular, what we've found is that it requires specialized monitoring in order to be able to anticipate problems before they happen. So we've learned a lot about that over the course of this last year and a half. But what we'd like to do with this is move towards a more low maintenance, more serverless architecture. And using things like Spark streaming within AWS Glue in order to be able to handle the job, which we anticipate is also going to give us potentially lower latency in our data lake environment and meet our analytics needs even better than they had in the past. One thing that we really got out of being able to deploy this data lake environment is that it really set us up for success going forward, because having the CloudFormation templates that AWS created for our disease surveillance data lake really enabled us to move quickly when the emphasis pivoted from case management and reporting more towards vaccine management near the end of 2020. When that happened, it became apparent that we were going to have a lot of analytics needs coming out of our immunization system. We were going to need a lot more integration points going into our immunization system. And it was in a similar position to where we were at the start of the pandemic with our disease surveillance system, where we anticipated it was going to be a substantial load onto the system, and we needed some way in order to take that load off and not have any interference with our transactional system. Because we had that template all set for our disease surveillance, we were able to deploy that very quickly, just pointing it to a new location for immunization system, and very quickly have a analytics ready, near real-time data lake available for immunizations in the state of Minnesota. What that opened us up to was being able to answer some requests that never would have been possible in the past. Because early in 2021, there were external partners, there were health providers, there were insurance companies that were all starting to ask the question of, can we run bulk queries against your immunization system to get vaccinations or COVID vaccination status? In the past, there had been some bulk query capability out of our immunization system, but the scale that we were talking about now with it, where potentially bulk queries of millions of Minnesotans were going to be coming in at a single time, it was of a completely different order of magnitude to anything that we had experienced before. And in the past, the answer to that question would simply have been no. That's not something that we can realistically support. But because we had the data lake already in place for our immunization system, we could confidently say, yes, we will be able to handle this. This is just using Athena and Glue on top of S3. It's all using serverless infrastructure. We knew that AWS was going to be able to scale out to handle the loads that we were talking about with this. So we were actually able to deploy this for our external partners very early this year. What that led to is more and more external partners were looking for the ability to do this. So while that core infrastructure in our data lake environment to support that bulk querying was still in place, and that hasn't changed fundamentally since that point, that's led to us developing and streamlining the process for the delivery mechanism for that query data to external partners. All of that's just by way of saying that because we were well positioned in our data lake environment at MDH, we were able to handle these requests and these unpredictable demands. So kind of summing up with the benefits that we've observed with our data lake environment. We have increased speed and efficiency in terms of our reports, both from our disease surveillance system and from our immunization system. We've gotten several reports from our epidemiologists of like the first time that they actually get results back from our data lake, their jaw essentially drops compared to the kinds of reports that previously had been running out of the application. They were like, I had no idea that I could get it this fast. Previously, my desktop had been spinning for like a half hour. And increased efficiency in terms of the vast majority of our data lake infrastructure is serverless. We don't have, aside from our Elastic MapReduce cluster that right now is being set up in order to handle refreshing the data lake, we don't have any permanently provisioned hardware associated with our data lake environment. Everything is on an as-needed basis. We have the ability to automate and then scale things out and experiment really rapidly. We've managed to deploy vastly more infrastructure and more analytics and meet more intensive analytics needs over this last year and a half than we ever had as an agency. Kind of as I mentioned before, leveraging serverless has led to reliability in our systems as well. Because we don't have that infrastructure to support, there's less operational burden. Essentially, the only real operational burden in our system so far has been maintaining our Elastic MapReduce cluster. Controlling access through lake formation has really centralized our security mechanisms across our data platform. In one place in the lake formation console, you can see exactly what data any given user has access to. You can control it from that one location. It's not something where people have database accounts spread across our landscape, and you have someone who, for example, we have a lot of people that were temporarily deployed to help MDH over the course of the pandemic, and a lot of those people have left since then. We don't have database accounts to clean up after them, or worse, have them lying around after the fact and then nobody seems to remember what this was for. There's a single place to coordinate all of our security to our data lake environments. Fast ingestion and consumption has really led to improved collaboration. Kind of like I mentioned before, we've had to meet drastically accelerated analytics requirements and unpredictable analytics requirements. And we've been able to do that. We've been able to meet those requirements in a way that never really would have been possible in the past. Frankly, we talk to our epidemiologists a lot more frequently than we necessarily used to. We're a lot more familiar, like there's a lot more people more familiar with exactly the work that they're doing and able to come up with solutions to help automate some of their work, to help reduce their burden. And just at a human level, that's really led to improved relations throughout our department. So the next steps for us, kind of the tagline for the state of Minnesota is the land of 10,000 lakes. So we're talking about the land of 10,000 data lakes. We don't imagine it'll actually get up to literally 10,000 data lakes, but there are a lot of people that are either very interested in developing data lakes in our environment or have already developed them in collaboration with us in order to meet their needs, even extending strictly beyond COVID pandemic. For example, we had, over the course of the pandemic, created a data lake for a syndromic surveillance system, which was, for Minnesota, a new initiative. That's not something that the Minnesota Department of Health had ever really done before. So very rapidly, as part of COVID response, it became apparent that we were going to have a syndromic surveillance initiative, essentially look at admission, discharge, and transfer records from hospitals across the state of Minnesota with COVID-like symptoms to try and anticipate where outbreaks might be before we had positive test results for people. So ingesting those admission, discharge, transfer records, which were in HL7 v2 format, that's not something that by itself we were going to be able to query in a SQL database, for example. But a data lake was a very natural place to ingest that data too, because we could simply ingest it as is. We could transform it, we could crawl it, and then query it immediately. And what's more, instead of having to worry about developing a full solution for querying all possible fields in an HL7 ADT, all that we needed to do with it was ingest that data, and for the subset of fields that were of interest for syndromic surveillance, we were able to develop some very simple Athena queries that just picked out the fields that were of interest to us. As the project evolved and as our vendor partner was able to submit more data to us, all we needed to do was add those additional fields to the table and view specifications in Athena. We didn't have to have an expensive and difficult data migration process in order to kind of upgrade to that new data coming in. So that has been immensely useful at the agency, to the point where there's another group in the same division doing analysis of traumatic brain injury that has been very interested in pursuing exactly the same model, because fundamentally they do a very similar thing. They rely on admission, discharge, transfer records in HL7 format in order to do their analytics. They have slightly different field specifications, but very close. So as a result of that, we were able to take the infrastructure that we had for syndromic surveillance and redeploy it very quickly for traumatic brain injury and have a working data lake for them. Aside from the business needs associated with data lakes, that's led to people on the IT side being like, like for operations, I'd love to be able to, just run queries of CloudTrail logs that we have associated with it in order to be able to better maintain our infrastructure. They were able to do that very quickly and easily. We just had things going into our S3 environment already. I was able to simply appoint Athena to it, and they were able to run queries against that right away. So for a long time in the pandemic response, we were stuck in like the single digits of data lakes in order to actually manage the pandemic. But as the pandemic response has gradually wound down and we've had more bandwidth for doing non-pandemic work, that's led to kind of an explosion of data lakes for completely unanticipated needs. So
awesome.
I'm going to pass that back over to Jason here.
Thank you, Derek. I mean, the moral of the story is, we go back to the flywheel, right? More data, better analytics, more meaningful impact, more users want it. It's not just a slide that we put up there and talk about it, it's realistic. That's what happens when you harness the power of these modern data infrastructures, data architectures. And I mean, the real call to action here is you're not the first to do it. This has been done before. We have a large collection of support services to help make sure that you're successful on this journey, including, Derek mentioned they went to AWS Data Labs. It's a 1-week immersive program. Just Google AWS Data Labs, talk to your solution architects and your account teams. They can help you get into one. Come with a solution, come with a problem, leave with a solution. You spend a week working full, long days with data specialists, your solution architects and service teams to help solve your problems. We have an extensive professional services and partner network that do this every single day. They know how to help you solve your problems. Tons of immersion days, workshops, and data-driven everything program. We're here to help you make sure you're successful on your data journey, and whatever we can do to help you, let us know. I'm going to close up with a thank you for coming out and spending your morning talking about data architectures with us. My contact's up there if you ever want to reach out to me, or Derek agreed to put his contacts up there as well. It'll be in the video. Please fill out the survey. Feedback is an important gift to us here at AWS, and it helps us iterate, evolve, and become better ourselves. It's our internal flywheel mechanism. So the survey should be in the application, and we only got a couple minutes left here, and I know there's another team coming in for the next talk. So if you have any other questions you want to talk to us offline, we'll be outside in the back of the room here in a couple minutes. Thank you very much for joining us today.